I'm going to be presenting Playground a Swift Introduction. So let's jump in real fast with who am I. I'm a software developer from Baltimore, Maryland. I work for a company called Planet Advertising, located downtown Baltimore. I've been writing iOS apps since 2008. In my free time, I like to play hockey, and I am a Poke master. I've got a buckle in my shirt, so let's talk about what we're going to talk about today. We're going to have a little overview of Swift. We're going to learn a little bit about playgrounds, what they are, what they do, why we should use them. We're going to see what we can actually do in a playground. And we're going to go to small app in Swift, utilizing playgrounds so we can test as we go and make sure that things are going to run the way that we're hoping that they're going to run. So, what is Swift? Swift is a new program language that was developed by Apple and released last year at WWDC in 2014. It works alone or side by side with Objective-C. We built to be powerful and fast. Very, very simple language, but at the same time very complex. A lot of niceties in it to make development easy for it. Once you get into it, but the learning curve is, I think, it's a little bit steep, but so far. Let's take a real quick look at Swift. We have a variables that are defined via either let or var. When you define via let, you're going to have a static variable. In this example, let static var equal foo means that we're going to have a string assigned to static var that is foo that will never be able to change. We also have var, dynamic var equal var. We have a dynamic string saved to dynamic var. Var. But we can always edit that, we can change it, we can delete it, do what we want to do with that.
Sorry, so var you can like change, and let is more like
correct. We have type annotations, which are not required. Swift is going to infer the type whenever possible. So in this example, hello world equal ni hao. It's inferred as a string because we're telling it, okay, it looks like a string. If we wanted to, we could always explicitly say this is a string, but since we don't need to, we don't. Functions in Swift. We have basic functions where we have a function name and it does something within it. We can also pass in parameters. To pass in a parameter, in your open parentheses, you add what your parameter is going to be named, colon, what the parameter is. You have to define the type of parameter that you're going to be or passing through to it. Otherwise, you're not going to be able to compile. Or you can also have a return value. If you see in your function declaration, we have add value to open parentheses, a int, b int, close parentheses, that little arrow, and then int. That arrow int says, this function is going to return an integer for our use. So what are playgrounds? Playgrounds are essentially just a file wrapper. It contains Swift files for your code, resources such as images, external APIs, other kind of resources that you need, and a timeline file. The timeline file is really cool. It shows you what your playground is doing in real time as you write it. You can always scrub through your timeline as well, so that you can see different ways for how your file is going to, or your code is going to interact over time. This is real good if you're doing like OpenGL work. You can drag around and see how your fixes are going to interact as your application runs. Now we know what they are. What aren't they? They're not where you're going to write a full application. Playgrounds are meant to be small, quick, and for testing. They're not how you're going to test your code on your device. There's no way to get your code from a playground onto your device. It's just test environment. It's not a way to test code that's going to require user interaction. You can't interact with a button or a label within a playground. You can create it, you can view it, but you cannot interact with it. Unless it's pragmatically so. Your user's not going to pragmatically enter access to your label. And then there's not a way to performance test your code. Since this is running directly within Xcode, it's not going to be very performance equal to your device or within your standalone application OS X. Why do you want to use playgrounds? They're a great way to learn, explore, visualize your code. If you're starting out with Swift, it's a great way to jump in and start writing code within the first couple of minutes. If you're trying to learn a new API, import it via the resources, play with it, see how it works. You can't break anything else because you're contained within your playground. Why not? It's a great way to visualize your code as well. For example, back again with GL code. Since you have the timeline so you can actually view what your code is doing as it's running, great way to visualize and make sure that your physics are right, and when that ball hits the ground, it's going to bounce where you want it to bounce. It's much quicker than creating a project for quick testing. So how do playgrounds work? Unfortunately, this slide is out of date as of last week because they updated them. Not perfect, but your code's on the left, your results are on the right. Every code change recompiles your code. So as you're typing, it is compiling in real time every time that you enter something. That way you can see what your variables are going to be when you type them. And then your timeline show results in more detail. Typically, up until last week, your timelines were in a separate panel to the right. Now the timeline is shown in line with the code. I really like the update. Hopefully they'll give us an option to put it back, but right now, that's what it is. So the features of Playground. You can quick look your variables as you run it. That's available for things like colors, strings, images, anything that you have. You're probably going to be able to quick look. If there's not a way for you to quick look built in, you can always build your own quick looks as well. I'm not going to get into that one today because it's actually kind of complex. Apple does have resources available for creating your own quick looks for within Playground available on their developer site. Worth the reading if you're interested in that. So your timelines preview your code as it's written, and you can view your changes in real time. As I said, also, you can also scrub through your code's execution in time. There's a bar at the bottom that lets you just drag along and see how it's going to interact as time passes. So, Playground versus project for testing. You're going to make a Playground, you're going to do file new Playground, enter the name, select which platform you want to run it on, OS X or iOS, and then you're going to write your code. Remember that's when you're working on a project. You have to create your project, choose your template, save your project, create the files you're going to need, write the code, set up your provisioning, build it, run it. By the time that that's all done, you probably already know what you were trying to do in your Playground and you're implementing that code into your actual project. So, let's play with the Playground. Alright, so I have Xcode open. Created a new Playground. That way we can see some of the features. Right button. So create a new Playground. We're given the option to name it. We'll just name it Openwest because here we are. And then we'll save it. When you create a Playground, you start out with these 3 lines. You get a comment, importing a UI kit, that way it's available to you, and a simple bar string. If you look to the right, you can see that it shows you what that string is over here. You know, if a quick look at if it were attributed, it would show you the attributes. Let's write a little bit of code. You can run for loops in a Playground. then visualize the results. So we can see that it ran 100 times. We can quick look it, and there's a little graph there. If we click this plus, that's going to bring into our timeline. As we get into this, you'll see why I prefer the timeline to the right. It starts to really blow up the entire thing. So now we can see that for loop in action. Let's look at how we can see colors. So we'll make a new color. Call it green, and then we'll have a color of red. By green here and fully alpha. So let's check out that green. So first we made our URI color of green, and let's quick look at it. It's kind of bright. So then we changed it since we defined it to be a bar. We don't get an error, and we're allowed to do that. And we changed it to take away a little bit of the green, and now we have a nice darker color. So that's one way that you can use your playground to just really tweak out your color and make sure you get what you want. If we wanted to add some blue to it, we can do that, and again, in real time, it will update our color, and we can see what we're looking at. We can also create views to preview within our playground. We're going to make a simple view with origin here 0, make it 200 wide by 200 tall. And then we'll set our background color on it to be our green color. So that's great.
Doesn't seem to prompt you and fill it.
It does have quick type, whatever it's called. I don't know why it's not really popping up for me right now, but it is there. Okay. So we create our view, and we'll throw this into the timeline. And now we can see our view right here. And it's a nice square with a green background, just like we thought. But it's a little bit tall. So we can simply adjust that frame. And refer. Oh. It's just so you guys have a chance to write it into the file. Try that again. All right, here's the back. That's my project. Cool. So we're back. As I said, our view's a little tall, so let's try to adjust that. We can change the frame of it directly in line. Okay, it does autocomplete for you. We'll make it, keep our width at 200, but we'll adjust our height down to 50. And look at that, we have an error, and it actually does show up in the code. Put it on the way, so apparently it's lying again. a quick look at it again and see that now it is smaller, it's just like you're planning on. Great for when you're designing your layouts. You can build them in a playground. You can drag and drop your code. You can throw it right back into your project. You can visualize it as you're building instead of having to build and run every time you make a change. You also have access to things like quartz. So if we want to put a corner radius on it, we can do that. And we can see the output of that. And we can see that we have that nice rounded. We can throw a label into our view. These are variables given to us at the very beginning of the string. And before we even throw that in there, we can quick look our label and see what we're going to see. Perfect. Outputs the text out you're expecting. And then we can add our sub-view. We're added to our view. And again, click there. But we really can't see that. So that's a real quick look at how you can design a layout via a playground. Like I said, once you did that, you can always just drag and copy your code, take that, copy it, drop it into our project, and now we have our layout done. We didn't have to build our code once. We didn't have to throw it into the simulator or onto our device. It saves a lot of time as we're building our way through the application process. So this is what we did. We used the playground to create a for loop. We created and modified a color. We created a view. We put our label. We made a view or a label. We put it into our view. We did all sorts of things. But what didn't we do? We did not create an Xcode project. We never built the code. So much more stuff that we didn't do just to save time. What else can we do with playgrounds? There's actually an API framework available, XD Playground, which gives you access to all sorts of cool stuff. We didn't create any custom quick looks, which are available for your custom objects. Like if you have a custom control that you've built, you can make a quick look so you can view it. We didn't use any external resources besides UIKit, such as API damages. And we also did not run any asynchronous code, which we can do in a playground as well. All right, so it looks like I have. So we're going to build something. We're going to pull application using playgrounds. I don't know if we have any XKCD fans in the crowd, but this is one of his comics from a few years back, entitled Geohashing. Basically, it's a fun algorithm to do something that no one would ever want to do. Drive to a random location and say, hey, I went to this location. So what's our goal going to be? We're going to create a fully functioning app in Swift. We're going to use the playground to test as we go, because rather than building and running, we can just drop it into the playground, make sure our code runs as we expect, and then drag it back and drop it into our project. There are a few caveats to this. Storyboard is pre-made. The project is already set up. There's a couple of files in there, such as our location controller and a URL connection that's already in place. And the code is all pre-written, pre-tested, just outside of the project. There's no way I'm going to be able to write a project or write an application in 15 minutes and have it actually run. So I'll make do with what we got. So let's build this project. So as I said, this project's already been set up for us. Our app delegate is completely standard. There's nothing special in it. I did create a core location controller. That way we can do core location. And there's the URL wrapper so that we can make a GET request to the server and records the response. The storyboard is also pre-made, as basic as it is. There's a map view, and that is all that there is to that. I'm also using CocoaPod for this for this Crypto Swift framework, but that's not here nor there either. So for our project, we're going to create all the variables that we're going to need. I'm actually going to have everything be dynamic, so I'm going to set them all to var. We're going to need to know the date, broken down by year, day, month, the open price of the stock market, some hashes. We need our core location controller. We're going to need to know if our location is available, if the hash is available. In our view did load method, we have to do a couple of things. We have to set up a location, a notification center, so that we can add an observer to make sure that once our location becomes available, we know in this file. We set our map view delegate to be ourselves, and we set our core location controller to be set up and the delegate or to manage the map view. We have a function call here, get DJI, with the save open price. The save open price is actually a closure, which we will see in steps 3. Let me try to look at it too far. Alright, so we're going to use this to get our document index. What we're doing here is we're actually checking to see if we can get the date and then generate a web call to this service, which is going to return back our opening price for the Dow Jones that day. We're going to use the playground to make sure we're getting the date properly. We're going to need to know that the date is an NS date. We're going to need to let the calendar go on NS calendar. Set to current calendar. So we see that our current date is in fact May 8th at 10:54 a.m. And our calendar has a nice object. So let's create some components for our calendar. We're going to need the year out of it. We're going to need the month out of it. And we're going to need to get the day out of it. And from the date of our date that we created above. So let's make sure that we're actually getting the right things. Let's create another variable called year. Set it to components.year. I spelled calendar right then, so. Got the unit. That's another great thing with Playground, because it'll actually alert you to errors in real time as well, just like the rest of your Xcode. Let's check and make sure that year is what we were hoping for it to be. Compile for me. If you're not running this on a 3-year-old MacBook Air, it's actually very snappy as well.
No, it's not showing. It is working.
Yeah.
I'm following along.
Proof. Does work. There, now we're not responding. There we go. I don't know why it didn't want to work, it was just crashing out on it. So we can see that our year is 2015, our month is 5, and our day is 8. So if I didn't already actually copy that in, but it did, we just simply copy that code over, up to our view controller, paste it in, and know that we're going to have the correct date available to us once we build our application. So we're going to run our request to our URL with our date bonus added on. We're going to take I hope we don't get an error back. If we do, we're going to print it to our console. Otherwise, we're going to save our data that's returned as a float. To our callback, actually, which we set as here. We set our callback, and we call it save open price. So we're actually going to run this function here. Once we return back our code properly. All that's doing is just saving our open price to our open price variable, and then we're running the generate hash. So generate hash. This is what we're using CryptoSwift for. We're just going to hash our string, which is going to give us our final hash, and then generate coordinates based off of that. When we generate our coordinates, we're actually going to need to do a lot of math. Go back to our XKC implementation. All right, so how this works. Our date is broken down into year hyphen day hyphen, or year, month, day, Dow Jones Index opening price. That is then MD5 hashed. So we have our nice string. That hash is split down the middle. So we have 16 characters and 16 characters. Using those 16 characters, we find out the hexadecimal value of it. We take our current location, which is on the left, so in this example 37, -122, and we put that in front of each half of our decimalized hash. And that gives us these two nice coordinates, 37.85 and -122.54. So it's actually a fair bit of math involved to get from our date to our coordinates that we actually want. So rather than trying to figure out this math as we go, and building and running every time that we think that we have it right, we can use our playground. So this hash is not going to be for today, but we'll take our hash and we'll set a quick variable to be our hash. We use let here because we're not going to be updating this hash. There's no need to make it dynamic, so we're just going to have a static variable. We're going to make some hashes. Or an array of hashes, which each one is going to be a double value, which is why there's a square bracket, and then the open close is just saying this is the array. We split our hash into two strings, the first half and the second. theory, we should run over here and we'll see that the two tabs are created. So, in the interest of time, wait for that to happen. Once we convert to our decimal, we're going to need them to be lowercase, so we're going to run a quick lowercase string on them. That way, any capitals that may be there won't be. In our example, we don't have any, but we never know what we might get, so let's sanitize just to be safe. Create another array, this one containing our two halves. That way we can loop around them. And then we're also going to create a variable hex, which we're going to explicitly call an NS string and set it to be the hex characters here with the rest. Now we can loop through our two halves, which are in split and E5. Create another variable, decimal. We're going to explicitly call it a double. We're going to set it to 0. In this case, we wouldn't have to explicitly say double because our 0.0 will let it know, but sometimes. I gave this presentation a few months ago, and everything went great. So I have 10 minutes left. I'm going to make all these files are going to be available to us or available to you guys. I'm going to put them on my website. So I'm not going to be able to continue the playground that way in the interest of time we can actually finish this project. If we weren't constantly freezing, we would have had an issue. So we'll pretend that we actually finished our math. We finished our math, it worked great. We're going to drag and drop it into our project. We can see that, or we now know that that our hashes array now contains 2 hashes in decimal format. Now that we have those, we'll check to see if we'll set our hash available to be true, and then we'll check to see if our location available is true. If it is, we'll add the pin. We're going to add a pin using the MK point annotations, MK annotations, set to our location from our core location controller as our main part of our location, our full number of -37, and we're going to append our decimal to it as well. Yeah, we'll append our decimal value to it. Once we create the correct latitude and longitude, we will drop it to our map. We'll create a new object location to be set to long, create a new annotation, given our coordinate from our object location, set the title of the geohash for the date, and a subtitle of our latitude and longitude. That way we can look at it if we really care. We'll add it to our map view, and we will set our view for annotation for the map view as well. So our location function, this is actually called by our notification center that we created back up here. It's just so that we know that our location is available, so that we can drop the pin on the map. It's not the best way to do it, but for this demo it works, and that's all that matters in that sense, I guess. And our last thing is our view for annotation for our map view. We call that in our set pin. It's just a way to make sure that we're not overwriting our location, our user location pin on the map. So that's actually a fully functioning application written in Swift. Let's see if it runs. It did. Alright, so once we get our location, sure, go ahead. To set our location to be right here in Utah. Your audio will come up in location, it will drop there. Alright. So we set our location to Utah. We can see that our pin is on the map. We touch it, we get our geohash, or with our on it. Like I said, it's a very simple implementation. It's not going to work if you do it before the stock market opens for the day. That's just going to crash it because we won't check to make sure that we're on the right day. Of that nature. So that is our project. Does anybody have any questions? That's what we did, why we did it. Anything?
You said you're putting it on your website?
Yeah, it's next line. Some resources for you guys as well. The WWDC session 408 is Tyler Swift Playground. The guys that made Playground presented it, and they're smart, so they know what to talk about. There's a Swift programming language on iBooks, written by Apple, provided to everybody for free. If you're interested in Swift, don't know where to start, get the book, work through it. And the slides are going to be available at jcurcio.com, as well as the code. That's the joined in hanging revolver. If you guys could rate it, good, bad, whatever. Just don't hold my computer freezing against me, please. And somebody needs to scan the QR code. Yes, people are doing it. Enjoy that brick roll.
I'm not going to scan it now.
Alright, so that is just about my time. Any other questions over here? Yes.
Can you talk about integrating Objective-C libraries in Swift, how
Yes.
that works, and what it looks like?
Alright, so Objective-C. When you want to bring in Objective-C, you need to create this file called your bridging header. You would have all your Objective-C .agent.m that you normally would have, and you would, in your bridging header, you would just say that you're going to import here. So in here you would do your import Objective-C class .h. Doing this, Xcode automatically recompiles your Objective-C into Swift. So everything in your header of Objective-C is now available to you in Swift. It's actually really simple, bridging headers. Pretty cool. Yes?
So, was it Apple's intention to use this language for the new iWatch?
I can't speak as to Apple's intentions on it, but you can write apps in Swift for the watch as well. It's completely cross-compatible across everything Apple at this point. Yes. All right, then I guess that would wrap up my time.